Hey, welcome back.
Hey.
Back to the routing loop. Once again, this is an Ask Me Anything session with Matt, and hopefully I don't have to disappear in the middle of this one and leave Matt high and dry. Matt, how you
Hanging
doing?
last time, Jamie. I'm good.
I did.
How are you?
I did. I'll give a brief explanation of what happened. Unfortunately, during the show, my daughter had gotten into a car accident. Everyone is fine. Everyone's safe. No one got hurt, but it was enough of a messy situation where I had to go and give her a hand. So once again, Matt, I really apologize for having to cut out on you, but thank you for carrying the rest of the show that particular day. Everyone is good now.
Yeah.
Knock on wood, everything is fine for this one.
We had a good discussion. I think Coding with Sean had a bunch of questions. I think Dominic was there. Hey, Dominic, I see you back then.
Yeah.
Reginaldo from Brazil. How we doing? And Chihuahua. Some folks joining.
Chihuahua. Cool. Thanks for joining, everyone. So, Matt, seeing as how this is an Ask Me Anything, also for everyone else who's watching in the chat, please bring your questions. It helps move the show along because it is Ask Me Anything. Thank you, Erie. Everyone is good. So, Matt, what's on the top of your mind? You said you wanted to do some scraping of some blogs, like right off the top of your head. You want to just kind of bring up to get everyone seated?
Yeah, let's see what. I figured we'd start with what's new in networking and just kind of do a running commentary on some of the blogs that we've been seeing get released. And that reminds me, I'm in the process of a blog right now, and I need to go and do some editing. I don't know. Have we had Andrew Gray on Twitch before?
I think I've had him a while back. That's a good person.
Okay.
That's a good person.
We should get him back on. Yeah, let's get him back on. He reviewed a blog that I was writing with some of the EC2 folks, and his feedback is always so super detailed. I need to spend some time to go and rewrite that. But so hopefully next week I'll have a blog that is live. What do we got here now? CloudFront Premium flat rate pricing plan. Bit of a tongue twister. Not bad.
Mm-hmm.
First centralized 13,000 VPC endpoints. This sounds like a cool architecture.
That does.
Actually, this is a model that I've seen with the financial services folks a lot, where the one I saw was basically financial services organization have a direct connect with a whole bunch of on-premises applications. They're now running a bunch of stuff in the cloud in AWS, but all of these applications are running in their own isolated VPCs. How would you get from on-premises to each of those isolated applications? You'd have to build a private virtual interface for direct connect to each one of those VPCs. So instead what they did, which I don't know what this architecture is, we'll scroll down in a second, but what they basically did is use a front-end VPC and use Private Link to drop about 5,000 interface endpoints into the central VPC that had the direct connect circuit attached to it. And so basically that they were brokering access, the network folks were brokering access using Private Link for on-prem to all of these cloud applications. Super interesting architecture and worked really well for them. Let's see what we got here. Shared services account. Okay, interesting. Implement Route 53 profiles. Okay, so there's a DNS spin on this one. I always love these posts where it's a real world use case. I'd love more detail in the diagram though.
One of the things, it's interesting that you bring that up because I work with FinServ quite a bit too. And one of the things I always recommend, I don't recommend, let's just say when they ask me, should you centralize your endpoints or distribute them? Our answer is usually like, it depends, business case. But I found that a lot of times when you're starting to do a lot of data pull through Private Link, it's a good idea to consider maybe distributing your endpoints versus centralizing them if you're going to go in a model where, not in the one where you're talking about where everything's Private Link connected, which makes a lot of sense. But if you're dragging it across something like a transit gateway, or if you're going to be dragging it across like a Lattice network or whatever, because then you're just paying for that data processing twice. You know what I mean?
So yeah, no, that makes sense.
Yeah, I think you need to. It would be a good idea for anything that does a lot of data move to put that endpoint pretty much next to, right, your workloads, and you can just go back and forth, take advantage of your 180 gig. But if you're centralizing across a transit gateway, if you're processing data, make sure that you're not sending the whole lot back, just so that you don't pay that fee going back and forth.
I always tell folks peering is still king. If you're in the same availability zone, peering, data transfer is free. Like use it. Peering isn't going away anytime soon.
Super fast. Yeah.
Yeah. Well, I think that the thing that I love about peering, well, don't get me wrong, I love Transit Gateway, Cloud WAN, and all of these other mechanisms that we've built to interconnect VPCs. But the thing with peering is a packet leaves a physical server, a host, and we just swap the VPC ID and send it on to the host that hosts the other guest VM instance, right? And so you're essentially going directly from instance to instance. So if you're in the same VPC, two instances, same availability zone, they're talking direct. Different VPCs, peered, they talk direct as well. And that's why there's zero data transfer charge for that. It's just a VPC ID swap, or we call it a GID, a global ID.
Yeah,
And if you're using Transit Gateway, you're going through a fleet packet processing, right?
Yeah.
That adds about a millisecond. Got some questions here. So tech first.
Yeah.
What
You want to read it out?
Routing policy. Yeah. Hello. I wanted to know more about Cloud WAN routing policy, confused with inbound, outbound, and ASN prepend. Jamie, are you up to speed on that one? I certainly am not. But
so Tech, are you talking about connecting things like inside or connecting with a direct connect, or are we also talking about things like send to, send via, and doing inspections between segments? Because I can yap or yammer on a little bit about that, but if you're talking about like looking at your traffic and figuring out inbound, outbound traffic between your segments, there's a couple of different methodologies. One of them is the send to and send via, where you can get your traffic inspected. So if you're doing a send via, think of that as like a bump in the wire. It goes to a VPC and then it goes to the other segment, and that just gets processed. And then if you're doing a send to, it means that if traffic is destined for this particular segment, send it to this segment directly first into this thing, and then have it take an action. So that bump is actually there. It's not in there. But I noticed that you're saying direct connect hybrid. What are you confused about with the inbound, with the ASN prepend? Are you thinking that you're having an issue with bringing your own ASN and connecting up with that? Are you thinking about wanting to preference one side or the other? Like what's the play there?
I think what could be interesting while we're waiting for a response. Here's a post by Jordan, actually. We should get Jordan back on to talk about what Cloud WAN and this specifically. So this is from 20th of November, 2025. I'll post it in the chat if it will let me. And okay, use cases, granular routing control, prevent suboptimal asymmetric connectivity patterns. Sounds good. Traffic engineering with path optimization. This all sounds great, but where is the diagram? Okay, first example, inbound. You know what? I find Cloud WAN to be confusing as well, and I think we need to work on our docs a little bit better. Like just at a first glance, trying to understand inbound route filter for a VPC attachment. Okay, that's how you do it, but why would you do it? Maybe I skipped over that. Yeah, interesting. I think tech first, that's a really good question, and we should probably get Jordan on to talk about that one, considering he wrote the blog, and maybe we can put him on the spot to have him explain how that actually works. But maybe have a read of this blog first, and there might be some good details in there. Great suggestion on a session. Also, Dominic, where was it? Here somewhere, said this. I think some time ago we had a topic about AWS backbone architecture and something about Nitro focused on networking. Yes, I love that topic. Yes. We should bring that one back.
Yes, you do.
Our backbone's super interesting because we're working with a customer right now who is basically hosting a, you could call it a security protection platform in AWS, where customers would connect to AWS, to this VPC, to instances that run their special source, that run their software. And then web requests are then forwarded onto the public internet, for example. And so with that, the AWS backbone is pretty powerful in that we do, essentially you could call it cold potato routing, where we attract traffic to our backbone, versus when I used to work on an internet service provider back in APAC, in Asia Pacific, we would try and punt and pass off traffic off the backbone as soon as possible so we didn't have to carry it, right? So we do the opposite here because we think that our backbone has better performance. So I think there could be a really good session in there where we talk about routing through a backbone. And in this particular case, it could be, imagine you're in Asia Pacific and you want to connect to this platform, which is in US domicile, perhaps in the United States somewhere. How would that traffic traverse? Would it hit our backbone in Asia Pacific and then use our links, which we capacity manage and really careful with, things like oversubscription and that sort of thing? Or does it follow a other provider who, I don't know this from experience, other providers potentially could be running higher capacity limits up to 80%, 90% on non-redundant links, and they could be seeing packet loss. We monitor all of our backbones. And so it'd be interesting to have a look at that use case, and maybe we can jump into some internet routing and say, okay, from APAC, do you go on AWS's backbone? What does the performance then look like to US versus going via somewhere else? Now, we haven't solved the speed of light, obviously, so latency would potentially be similar, but maybe we could test things like jitter or packet loss or what the routing path looks like. That would make an awesome session. I'm going to write that one down.
I'd push back a little bit on the routing looking similar, only for the fact of in another life, I also worked not in Australia, but on the East Coast with an internet provider. And I remember one of the things that would be interesting to me is when we would hook up our service, the service I was working for. I don't want to name the company, but it's fairly large and folks know it. But if we hooked up our service to somebody else's service back then, you remember NAPs, network access points, like how many? It was a big thing of like how many NAPs do you take to traverse? Meaning how much of the wire is yours? Because once you reach the boundary of your wire, you go to another network access point, and then it's somebody else's wire. And as we all know, every hop has a cost. So you're right, we didn't solve the speed of light, but if we also keep putting blockers in front, or roadblocks, or road checks, I should say, that slows things down. So when you're comparing the AWS backbone versus, say another backbone of another provider or somebody else, and look at the path, how many NAPs, how much controls do you have to go through when you're on a network that's compiled of multiple providers versus one provider that knows everything end to end, optimizes everything end to end, that kind of thing. That would be an interesting look. Like, am I just thinking of these things? Or is this, you work most with our backbone. Am I just thinking of this as hey, this is a non-issue, or would that actually cause an issue when another group of providers versus a sole provider has like different?
So BGP is supposed to solve this. And I'll just move Dominic's message out of the way here. Yeah, BGP is supposed to solve this with ASPath, right? I mean, it's essentially how BGP works, right? And if you imagine two different paths from APAC to the US, to a US region, one is via partners, and that could be going via 3 autonomous system numbers. The other could be coming straight into AWS's backbone and then follow 7224 all the way there. So anyone who's looking at BGP prefixes would say, well, I've got 3 or 4 different ASNs via path A, or I've got one via path B. I'm going to choose path B, of course, because it looks like you're going through less hops. So hopefully the way that we advertise routes out into the public internet would then reflect that, and we would be the preferred path to use our backbone, because I do truly believe that you would get better performance with our backbone, just looking at the engineering that is involved internally around that. Now, to your point though, if you were, and there are other ways to influence BGP prefixes, like using communities, and you can basically have outbound or inbound prefix filter lists to apply different policies to different routes and say, actually, it's cheaper for me to send traffic via this path versus that path, so we're going to punt traffic down a different path. The problem with going over multiple providers typically is the peering connections, because you've got provider A, provider B, provider C, they all need a connection between them. And the problem with peering or transit, 2 different types of communication between providers, peering, both ends agree that it's in their mutual benefit to have a connection between them, a 10 gig connection, a 100 gig connection, an N by 100 gig connection. But they both have to pay for that, right? And they're both almost begrudgingly saying, well, we send traffic to you and you send traffic to us, so let's then build this peering connection. Someone has to monitor those links, and they could become a bottleneck if they're not capacity managed closely enough, right? The other is transit, where smaller provider A talks to larger provider B and says, I want to use you to transit traffic. I'm not receiving much, so you can't offload much, but I'm going to send a bunch. And provider B then says, well, I'm going to charge you money for that. And so it actually
Right.
costs dollars for that first provider to send traffic to provider B. And so in that case, provider A may say, well, we're only going to pay for a 10 gig or an N by 10 gig. We're not going to pay for 100 gig. And so that could be a bottleneck too, because they want to reduce their transit costs and try and send you via a different path that may be via a peering connection. So there's all of these dynamics in play when it comes to internet routing. And the reason why I love the AWS backbone is we're basically just like, it's global, it's one big fat thing, and just
And it's
give us the
all
traffic and we're going to keep it on our backbone and capacity manage it. And we've got a whole bunch of operational processes around keeping that backbone alive and multiple links and paths. And there are some cool stuff. We don't talk about future features here on this show, sadly. I'd love that. That'd be awesome. But there are some really cool innovations coming with our backbone around, think about things that you could do with traffic engineering on multiple paths, right? So if anyone's interested in that, reach out through your account teams, Jamie, and I would love to chat to you, because there are some thoughts out there and some things that might be.
Yeah, feedback is something that we really, really admire. It's funny when you mentioned the providers offloading to larger providers. The analogy I given not too long ago, actually, when we had a discussion, it's the age-old discussion. If I have something on AWS and I go over publicly on the internet and offer it, and I have another customer on AWS and they're letting things go off on the internet and we connect together, are we actually going on the internet or are we staying on the AWS backbone, right? And of course we are staying on the AWS backbone from one AWS account to another. But we got into this discussion about third-party providers and offloading and how that looks. And they were a little confused on it. And I gave the analogy of, companies like AWS, companies like Verizon, companies like Google, they build throughways, right? These really large, can handle multiple packets cars, right? Going in multiple directions and a lot of road signs, and it's always under construction, everything else. And some of these smaller tier providers, they're like the routes in the US, at least, routing traffic. So it's still somewhat streamlined, but it's not necessarily a throughway. You might hit some stop signs. You might be going through an intersection or two. Your speed will go up and down. So what they do is when that gets congested, they tell people to go on the throughway and they'll happily offset that cost so it doesn't bring down their infrastructure. So that's usually the way, via analogy, I'd like to describe those things.
Yeah. No, that makes sense. It's interesting when you think about service providers and them being, they're essentially a throughway to a data center, to a server. If you think about AWS and our legacy, it's really, we started, and I'll use some terms here of when VPC was first made, we designed it as a cul-de-sac. So an endpoint, a thing that you send traffic to. And we basically said, okay, let's pretend we start with one region way back when. And I don't even know what we did start with. Maybe we can check that out. But we start with one region as a hub, as a destination with instances, servers that are running there, serving data. Then you expand out to 2 data centers, 3 to 4 to 2, 3, 4, 30 regions. And now you've got this backbone that interconnects everything. You're now no longer just the hub. You are the destination for a lot of that traffic. But exactly what you said around public internet connectivity, when a source of traffic leaves a VPC, for example, and is hitting a public site, you then, let's say that site, Matt and Jamie's tractor shop is on AWS as well. You stay on the backbone to hit the Elastic IP, which is then representing an NLB, for example, representing a fleet of instances running Apache or something similar, right? And so you've just stayed on AWS's backbone for that whole thing. There is public connectivity there for sure, because you're using public IPs. You're on a public backbone, but you're on I don't know if I want to call it a private backbone, but it's a owned by one entity backbone, right? And
yeah,
so
like how would you call it? Like a sovereign, locally governed AWS.
Yeah, I don't know what the right term is. There is a term for that.
Process. Yeah, exactly. But it is still out on the internet, right? It's advertised. The routes are there. The routes are advertised out. If somebody knows that IP address, they could try to contact you, because we do have connections to other sites. Yeah, I could talk about our infrastructure all day long. I remember I saw a presentation that was done a while back where they showed the sea cables that they were laying, and how, it was like this, they had a boat and it was just laying this undersea cable. It was absolutely fascinating. And then I think also on that video, I'll have to look it up, but it talked about how on the jackets of the cables, the outer layers of the cable is DC power. So all they do is they can monitor with the DC power. They send voltage down, and they have these things that are almost like the old, remember the 10 base T vampire clamps? where it used to basically just bite into the cable. And that I know I'm dating myself there, but anybody else in the chat, if you guys remember that stuff, just say I remember, so at least I'm not alone. But it's very, very similar for the undersea cables, where it taps into the DC jacket that runs this, low. It's not like we're electrocuting every fish in the ocean, so it's very low voltage. But the neat part about it, the security way, is the way that they put these devices in. They can tell if anyone's tampered with the wire, because the voltage will be different if someone cuts. And I just thought that's the simplest but coolest way of figuring it out before like your cables start going dark. You know what I mean?
Right. And I forget how many miles they have these things. They look like a giant big copper torpedo where the power is actually powering these things. And I think it helps with helping the light pass through the fiber as well. There's all these other different mechanisms too. I heard of one where they actually pump light down the other end of an undersea cable, and that excites the light photons, or whatever the term is, to get more distance out of undersea fiber. Right? There's so many fascinating things.
It's like what is it? Like light lubrication? I forgot what I know what you're talking about.
I don't know what the term is. Yeah,
it is pretty cool.
I have a story that it's a non-story. But we were running fibers between Sydney and, I think it was Sydney and Guam. We were running a new fiber to go Sydney, Guam, East Coast, or West Coast of the US. And we rented a ship. This is my other company called the Ile de Rue. I think it's owned by Alcatel. It's a cable laying ship. You can probably look up the Ile de Rue. They have these huge big barrels inside the ship that are the diameter of the ship. And that's where the cable is carefully laid inside the ship. And they basically just start sailing over, I don't know what the term is, but from Sydney, they just drive and just drop fiber out the back of the ship all the way to Guam, right? Which is insane to me. So we had a tour of the Ile de Rue, and I was super excited because I don't get out much. I was a network engineer in a basement doing
we don't touch grass
networking equipment. Right. But that morning I woke up and I don't know, I was sick or something, and I didn't get to go and see that ship. And then the next day the ship had sailed, so I missed out on the tour. But yeah, that it's fascinating stuff.
No, I love it. I think we got a couple of questions. Dominic wants us to draw the entire AWS backbone.
I mean, that would be great. That would be a good test. I did not bring my iPad today, and I regret that. Okay, we got some other questions here.
So how to build
AI agents that don't? Oh, you go, Jamie. Go for it.
Yeah, sure. How to build AI agents that do not hallucinate when using low-cost models like Claude 3, Haiku, and AWS Bedrock. It's funny. I've been playing a lot in the.
This is a good segue, even though it's not a networking question. It does say "Ask me anything," so.
Yeah. So I've been playing in this world quite a bit, and I've been using our Kiro CLI, and I've been a couple of other tools. And as some of you may or may not know, I'm on the service team as well. I had joined the service team, networking service team, after Matt, and then of course Matt found out I joined, and then he left because making wise decisions, and it's just a joke. Anyways. We've been doing a lot with AI agents, and a lot of the things that I've been reading and looking at, when the hallucination usually happens in the middle, right? So just like a human conversation, we always remember the first thing and the last thing in a conversation really, really well, right? The beginning and the closer. The stuff in the middle kind of gets lost, and an agent will look for the stuff in the middle, and I'll look at the beginning and look at the end, and depending on how long the conversation is, we'll try to approximate the middle. And in that approximation, it gets hallucinations that if it doesn't have all the data available. So one of the ways around it to kind of keep your agents honest, if you will, is two ways that I've seen that works for me, right? The first way is keep your context in your conversations as small as possible, right? So when you're doing something complex, break it up into smaller bits. Don't do one long conversation, right? And now the next question is like, well, if I do that, then how do I start from zero over and over and over again? So that's where you create really well-defined specs or really well-defined documents that help the agent get on track when it goes to the next segment of your project, right? Filling them in just enough, or them in, or whatever you want to call them. It's funny, I anthropomorphize them a lot. But you fill it in just enough so that the hallucinations don't get lost. Now, the big question comes down to do I do this? How often? How much do I cut the work up? And that really comes down to one other fact that most people don't do, is that you need to fully plan out what you want to do beforehand, right? I know vibe coding is a thing, and everyone wants to be able to sit down and then make the next coolest app just by thinking it and typing it in midair. But let's be honest, nothing great happens, in one stream of consciousness. It usually happens with lots of planning and thought and edges and figuring things out. I was just kidding with Matt that I was messing with something that literally destroyed the laptop computer I was working on because I didn't think about, compound regression and things where like I'm setting a thing in motion and it's constantly eating more and more resources and compounding itself. So it's, old engineering rules, whether you're an infrastructure engineer using AI or if you're a software developer, they still apply. You still have to figure out all those things and map all that out before you go. Just now you get a little bit of extra help, but you've got to keep their memory alive. So that's my long-winded explanation of how to do it. Break it up into smaller work. Make sure that you produce, your agents produce files as well for not only like your product, but also to keep tabs of where you are in a product so that when you switch back and forth. And then a last thing too is really, really important is context switching, right? So when you're working with an agent, whether you're on an IDE or CLI, and you keep working and working, you fill up your context window. And that context window will build a bias. So if you're producing code from the same window that you're architecting from, it's always going to be biased. It'll even get to the point where people are like, this agent is lying to me. It's not really lying to you. It's just trying to connect the dots that you want as fast as possible, which might be even completely circumventing the code you want it to write. So building a spec in one and figuring out what you want, then carrying it over to a completely different agent or chat, right? And using its fresh context based on what the detailed specs you want to build will help you build better products because you don't get that context bias. So
I'm very simple in my use of agents and contexts. And I have two funny stories actually. One is just how I'm using LLMs on a day-to-day basis with a million token context. And I'll just add documents, files, context details, meeting transcriptions, and just try and beef it up as much as possible and then use it to write updates and things like that. I end up, there's a sweet spot there where I'm about 75% of my million context window, and this thing is great. It's amazing. When I get further than that, it just starts hallucinating. And I'm like, no, please don't break. I need this.
Yeah.
The other thing well, we can talk about that actually, because I think that's interesting. We do have some networking questions, so we'll come back to that. I did see a funny, not funny post on our internal Slack from someone who was using Kiro recently, and they were in YOLO mode, which doesn't ask for permissions, and there was a typo in the instructions, and it was ~documents, so the documents folder, but the C was a capital C. And you could see the thought that was happening. And Kiro said, "Oh, I'm doing this work. Okay. Oh, wait, there's a typo in the documents thing. Let me just delete that one and then restart." And it did rm minus rf ~documents, and then went, "Oh, data loss, stopping work."
Yeah. That's not good.
It's obviously capital C versus lowercase c.
Yeah, the system I built, I put a bunch of guardrails in. If anytime you're going to delete something it's not part of a get repo, it has to like tell me, do you really want to do this? Because I swear I did the same thing, not with a C, but a different deal. And I'm like, I got something kind of working. Again, just starting out, I edited the code some of myself in the beginning because the system wasn't doing right. I'm like, oh yeah, just go ahead and do this and commit it. And it basically moved it into DevNull. I won't tell you how it got there because there's some issues that were my problems too, but it was not fun. If you move anything into DevNull, it's the same as rm minus rf. It's gone.
I just get frustrated saying, yes, you can do this. Yes, you can do this. Yes, you're allowed to do that. Yes, you're allowed. And in the end, I'm like, just trust, go, YOLO, do it. And then it says deleting everything now. Let's get back to networking. So TechField says, when traffic leaves the NAT gateway IGW to communicate with, let's say another EC2 instance with a public IP, why does that not traverse the public internet? What I said previously is correct, and what you're saying now is correct as well. It is the public internet. You are actually out in the public realm talking to public IPs. But when you go from one VPC to another within, say, the same region, for example, one Elastic IP to another Elastic IP, you're on Amazon's backbone. You're not actually going out into the right term is probably a third-party provider's backbone. You're staying on Amazon's backbone. Now, the reason why you should absolutely consider this the public internet is these two public IPs have public access. you're allowing other things to reach and hit those public IPs. Anything in the public internet could potentially send traffic to one of those public IPs, and you would then lock things down with security groups to say, actually, I don't want that traffic happening. So it is the public internet for all intent and purposes.
Can I use another analogy? I love using analogies.
Yeah.
Think of this like the mall, like for the ones that still exist, right? You've got all these different stores. Those are customers. The mall itself is AWS, right? Now, those stores can have exits out of the back of the mall, so people can come and go normally. But that section where everyone's walking back and forth in the lobbies and all that stuff, and sitting down and having Slurpees and all that stuff, that's our backbone. It's encased in our walls, but the public can come and go with it, right? So that's
from one shop to another.
One shop to another. So that's how I would do the analogy. How did I do? We have to rate my analogies. You got to do like an analogy score of how well I'm doing this.
I'll give you a score out of 18. I'm thinking that was pretty good. That was maybe like a 14.5 out of 18.
And then you guys too in the chat. Give me your ratings on how my analogies are. We'll keep up with this theme.
All right. Next one from Ken. Hey, Ken, is there a way to access CloudFront distributions without using a NAT gateway from a private subnet? Hint, hint, PFR. I like this PFR, but it breaks one thing. CloudFront distributions are public. They're on their edge locations. They're on the public internet. Speaking of public backbones and public things, the VPC is private. And so NAT gateways operate on a fleet hyperplane running inside a subnet, which is typically a public subnet, but it would have a NAT gateway has a elastic IP, so it's able to talk to CloudFront distributions, for example. If you've got a private subnet, there's no routing to the IGW, there's no elastic IP, you can't go out onto the public internet. Now, what I think we're saying here is, what if there was a private interface endpoint from CloudFront that was able to then be dropped privately into the VPC? You would then rely on the local route of the VPC 10.100/16 via local to communicate with that endpoint. I like that idea, but there's one place it breaks, and probably two reasons why we probably don't have this yet. The first is private link and interface endpoints are a really good mechanism to get to other VPC things. And so what you typically do is you have an interface endpoint that it's just an ENI or set of ENIs that talks to private link, which is hyperplanar fleet, which then talks to an NLB in another VPC, right? And so you've got this private connectivity. In this model, the NLB/destination piece would be CloudFront distributions or edge locations, of which we have, I don't know what the number is. I think it's 700 plus the really small ones. I forget what they're called, but it's like 1,200 or more. I don't. We can double check. Actually, we have some classifications on what they look like. But so there's no hyperplane fleet or private entity on the other side that you could connect to. That's the first reason why we probably don't already have this. The second reason is this breaks the illusion of privacy that you have with a VPC. And so the VPC it's a border. And so if we start bringing public access into the VPC that doesn't go via the IGW, a lot of folks get upset because they say, well, hold on a second, the VPC is supposed to be private and you're only supposed to be able to go out to the public internet via an IGW, via what we call Blackfoot, which is the internet edge fleet that connects from private realm to public realm. And if now we're opening up another connectivity piece or path of connectivity, it kind of breaks that feeling of privacy you get with the VPC without an IGW, right? And so I think we did do something similar with Global Accelerator. Jamie, you have to help keep me honest here, but I think when we launched Global Accelerator, or I'm not sure if we can still do this, but you could get from Global Accelerator, which is a public realm, into the VPC without the IGW. And I think a lot of folks were upset by that. I'm not sure how that works today, though, because I'm not sure if we actually went back and changed that or not. We can double check.
Yeah, so with the Global Accelerator model, because of the fact that the Global Accelerator has 3 different types of endpoints, where you can do the IP, or you can do, actually it's IP or ELB, right? ALB or NLB. Those are the 3 different types. When you're going through the ALB or the NLB, that's a vetted proxy device, right? So as much as you want to do, or even with the IP address, you can go directly to the IP address, and that's typically done through the IGW. So if you're removing the IGW and you want to go privately, it's only to an ELB, I believe. And that ELB is already a vetted threat surface device via a proxy device that has security baked in. If you're leaving out of an NLB or an ALB, you get the external IP address of the NLB and ALB. You also inherit their security groups, you inherit their listener rules, all of that stuff.
I guess you're going the other way, right? If it was CloudFront, you're talking inside to outside to public realm that could be anything. The other way around is really Global Accelerator. You're hitting a Anycast IP. I know it's more special than Anycast, but then you're coming into something inside the VPC. Right. Interesting though.
And then with the CloudFront example too, you're absolutely right. It's a threat surface that we have a known. An origin is different than an ELB. An origin in CloudFront can be just about anything that you can connect to. So the rules will have to be extremely tightened if we did a PFR for this to be able to understand what the threat surface would be if we're poking a hole in an impermeable VPC that's only supposed to have the methodology of using an IGW, which is a known portal or a known front door where we know how to secure that down. We know it does. Secret is not really a secret, but it does its own NAT as well. It's highly monitored per each VPC of what comes in and out. So there's a lot of protections that we've had for many years now, ever since VPC's been out. So the last thing we want to do is poke holes in the side of the VPC for all these ancillary services. That needs to be really well thought out and tested. No analogy there, so I guess that gets a low score.
Yeah. No, I think we answered that one, but we should put a PFR in anyway if we can.
Yeah, exactly. It doesn't mean that it's impossible. It just means that it needs to be thought through. That's all.
Yep. No, I hear you. And Jamie, your friends in your networking services org are CloudFront anyway, but so maybe you can give them a bit of a poke. Tech Fuel, another great question. Jamie, this one's all you.
We are evaluating SPIFFE and Spire for multi-cloud workload identity. But for intra-AWS communication, I believe VPC Lattice combined with IAM auth already solves most of the practical security problems in very AWS native way. We'd love to understand how other large AWS customers are approaching this and whether you're seeing VPC Lattice positioned as a practical workload identity control plane within AWS. It's a great question. And very good intuition. You're right. This is because remember a lot of agentic workloads, and again, I've been swimming in that pool quite a bit lately. That's all layer 7, right? And VPC Lattice is all layer 7. And the cool thing about the Lattice piece is like, if you have a chat or some sort of agent that starts out in a VPC and you want it to talk to another agent in another VPC, and you need to make sure that it's enforced, like you have specific rules. I want it to be encrypted, or I want it to follow this specific path, or it can only talk to whatever individuals. Putting those inside of services and having those service profiles that you would set up for security, as well as the service network profile of saying, hey, this is how you have to talk across my network, is a perfect fit. And IAM works out very well because it is very, very tunable, right? You can pretty much create an IAM policy to do just about anything you want. Just don't do it too restrictively, of course, on the service network. But yeah, a lot of the larger organizations are looking at it very much the same way. I was talking to Matt earlier before the show and our producer as well. The thing that keeps me up at night is now we're seeing more and more agentic workloads, more agents, as opposed to just packets, right? Doing communications between multiple companies. But the difference between agents and packets are, you have a packet, it goes to a firewall, here's my payload, here's my header, this is what I'm going to do, reject or deny, right? Even if it's an attack from like some evil person corporation, it still follows the same rules, right? This is a packet, this is what it's destined to do. Maybe it's allowed, maybe it's not. Maybe they're trying to do something funny with sending too many DDoS attacks or whatever. But an agent has an identity. And you've seen Google's come out to like with A2A, right? Where basically each agent has a business card and those business cards are exchanged and can we speak back and forth. But at any given time, an agent can switch its identity depending on how the agent is made, right? It can fake its ID if it's coming from an attacker. So if we're looking at it, bad corporations, and this is not even addressing someone making a mistake, the accidental RM minus RF. Imagine if you have an agent carrying some form of command or controls to something else that doesn't have any checks to it and says, hey, I want you to blow away this entire table out of a database. No context, no reason, why. If those controls aren't put into place, like using something like a lattice, like, hey, something like this is not allowed, it's pretty easy to do. And again, think about how easy it would be then to attack. You can have agents that basically compound upon each other, and they go out, get information, come back, use that to build a better attack, go out, come back, go out, come back, until eventually they get in, right? Like a swarm, if you will. I'm expecting to see a lot more companies, not just us, and I can definitely tell you we are working on this problem. But a lot of other companies as well are also trying to address this. So yes, internal AWS, I would definitely look at Lattice. It's the L7 way of doing things. Play with Agent Core, right? Send out some agents. See if you can restrict it down to blocking. That's the thing too, is like make sure you can block the agent itself, because you can design them to be like find any path. And if you try to block something within VPC Lattice, you can say, hey, don't get to this service or don't get to that service, but yet you have traditional routing that gets to those services, and your agent is smart enough, it'll be able to go and find it. So yeah, that's I know it's a long-winded question. Again, no analogies, but it's very interesting. And again, it does keep me up, because just this, if I had an evil mind, I could be on the news and in jail real quick.
Well, I mean, and that's a scary thing about agents, right? You just have so much detail at your fingertips now. I love this comment from Robert Tables. Context would know is like the Obama peak with Dream King. Yes, I agree.
Yes.
Okay. What else have we got here? Lots of good questions. How can we optimize costs when building an AWS Bedrock agent for a financial deep analysis using knowledge bases while leveraging cost-efficient foundations such as foundational models like Claude, Sonnet, Amazon Titan? Do you want to take this one, Jamie?
Yeah, we can. Honestly, I'm going to be very, very honest with you. Right now, in the world we are with agents, it's a trial and error thing, right? So the payoff comes at the end, is what I'm going to say, is when you're playing with agents, right? But the payoff only comes with the preparation and testing that you do now. So if you want to optimize for cost, when you build your agent, you actually have to run it through a model, or you have to run it through for me, I built these things that I just call them training gyms, if you will, where I'll build basically a construct that I send the agent through, and it has to basically pass these hoops to be able to get to the other side. Just your standard everyday, inline testing of how I want something to be done. And one of the things, actually a couple of the things I do, is cost. And the way I usually control a lot of cost is like, again, if you're looking at a chat bot, it's tokens and context. Like, how do I make this as low as possible? And when I'm thinking about cost across a network, right? If I'm sending them from one section to the other, how many paths is it taking? How much data is it transferring? Does it need to transfer all of that data? What can I do to set up a stream? Is there any way that I can offload? Like, one of the things that I've seen some companies doing is they treat agents, or they treat any of these things like they're dump trucks. Put everything on an agent and send it across. That's not necessarily the best way to do it, right? Some of the, traditional networking is not dead. One of the best ways that I've seen that some companies have done is they've sent an agent across and say, this is how you get access to this data, and it's only going to last from this time period, right? And then the agents are the ones that are keeping it up and are actually watching the data flow, but you use more of a traditional data stream. So it really kind of comes down to what you're trying to do with the agent, but running it through a test and building a conditional, right, to send it through, like a testing model, will get you to the point where you know what that agent's going to do and what its cost is going to be. That's one of the coolest things about them, is that you can kind of synthesize a lot of these environments and figure out what that's going to do and what that might look like on your network. But remember, don't do everything within one context window, or it'll start lying to you. It'll be great. It'll cost you nothing. Just send it out. Can I do that for you? Just press send. That kind of thing.
Right. I think just, I have another funny story about this, or a funny thought, but I think just selecting the right model for the right task too, right? I mean,
that's a big one.
If you're using super expensive Opus 4, 4.7 to do some standard text manipulation, and it takes a while, you're going to be burning through twice as many tokens than if you use Sonnet or something like that. There was a drinking game which actually, I think it was in Dublin, with Tom Adamski and a couple other folks. And part of it was we were just sitting at a bar somewhere. We had an event out there, and we made it so you couldn't say particular words. And so you couldn't say, I would like, or I forget what it was, but we ended up speaking like we were just cavemen. When you'd have to order a drink from the bar and you'd say, me beer 5 or something like that. But
that's funny.
But the thing is, when you're talking to an agent, there's this idea that you could talk with like caveman or cave person speak and save on tokens. Right? Instead of giving it the full length of your prompt, like cut it down. And someone did some analysis on people are saying please and thank you to agents and how much GPU power that was actually consuming globally when we didn't really need to, even though we're trained when we grow up and learn to do human interaction to say these phrases and things, but it's actually costing electricity for agents to then process those tokens.
Can I share my screen for just a second? I want to show you something.
Yeah, please go for it.
All right, let me see here.
You don't have to ask me. Click the next button.
Yeah, share screen, Chrome tab. All right. So for me, working with, basically working with agents and whatnot, I've tried to make it so that I can reduce the context load of what I'm talking back and forth. So remember when I said you want to get rid of context bias. So I have this thing, it's called IMP. It's basically named for impossible. This is actually a chatbot that I have running right now. And then I built one called Veritas, and I built another one called Anvil. And actually this whole dashboard I built using this system, and that's how I know it works, because it doesn't crash every 5 minutes. And if you can see, it doesn't also consume a ton of memory to run.
Well, all I can see with IMP is a Protoss pylon.
Oh yeah, exactly. From Starcraft. It's, believe it or not, that's kind of where that came from. And then this will change color and basically, but the thing I want to point out is I made a bridge, right? And they communicate back and forth. And that communication is very similar. And pretty soon, like I've got a nerve gate, and then there'll be another external thing that I can do and send back and forth and contracts and stuff. But the idea is when I'm talking to this particular one, this is the one I design with, right? And then when I'm done with my design, I send it to Veritas, which is Latin for truth. And its context and everything is focused on poking holes in everything. And it's mean. Like realistically, it pushes back like crazy. And that's what I need it to do, to find all the bugs and holes. And I go back to this one, right? And then I continue on my design, go back and forth until I get full green from this thing that absolutely is tuned to hate everything that I say, right? It's not really true. It's basically tuned to poke holes and everything. Once that's all done, I go to this thing, another chat called Anvil, and Anvil builds it. And Anvil gets specific instructions after this back and forth, right? Anvil will get the specific instructions, and those specific instructions allow it to build exactly what I need. Now, granted, it's not always perfect code, but the code is a lot better than if I say vibe coded it, right? And I can still iterate. And once this is done building, it goes back to this Veritas thing. Veritas will validate its build. If it finds any problems, it goes back and forth. And I keep using this model going back from one to the other. Now, to tell you why I'm thinking and why I'm saying this, if I were to send these messages back and forth, and I built this bridge, right? And the bridge is encrypted and it uses a whole bunch of stuff, but I built this bridge.
What is a bridge? Is it like a SQL database or something like that? Or?
Oh, that's a great question. The bridge is basically, I did it with Unix sockets. So it's a daemon and it listens on a Unix socket level. And that mimics when I go through here, which does WebSocket to the outside world. The communications are the same, whether it goes over the nerve gate or it goes over the bridge.
So basically any prompts and responses are getting fed through the bridge, and the bridge is then tracking and keeping and it goes from one index.
Yeah, it goes from one to the other. And then I literally have to go to the other chat because I still need that human element of control to say, check your messages, right? And it'll check, gets the message, gets the full context. Now, when you're sending stuff back and forth, if you're sending these huge context messages of like, hey, I want you to validate all these things, X, Y, Z, blah, 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 that's going to eat your context windows on both. It doesn't serve anything, right? So what I did is I built a mine. And this mine is a graph database running on top of SQLite. And it's just a bunch of memory nodes, and they're all interconnected. So I can see like what I want it to do for my demos. And these nodes, actually I can blow up a bigger one. These nodes have lots of interconnections back and forth, right? And those interconnections are basically strengthened or weakened based on how many times it's communicated, because I need this to not fill up my hard drive, right? As you can see in my system resources.
I was going to say,
nodes,
you're going to run out of memory, friend.
well, see, these nodes here are not connected. They basically become forgotten, and they'll just go ahead and be archived, right? So then this actually will be pretty tight and self-runs. The point of all of this, now when I have imp talk to Veritas or imp talk to Anvil or any of them, it sends limited context, pipe language. If you're used to Unix, you know what pipe language is, right? That's what it uses. And then it also sends pointers within this memory graph or brain for the rest of the full context that it writes. So it offloads it, right? Sends it to the pointer, and then this one picks up only what it needs. So you don't have the pleases, thank yous, yes, nos, even spaces, right? Take up tokens. So I eliminated all that by just basically having it read using machine language and then having a persistent memory. So that's how I do it anyway. And again, I'm pretty pleased with the way that the code is working.
This is far more powerful than I'll probably ever need. But that said,
I mean, that dashboard I built with that system.
Right. Well, I imagine this is going to be super important for when you start to deploy things like agents across across service VPCs connected into VPC Lattice, and they're performing operations and have access to data, and you need some kind of coordinator to then manage all of that. And I mean, I'm by no means an expert in this, and I'm very limited in my cave person speak to my local LLMs doing whatever I'm doing, but I could definitely see this.
I did kernel. I made kernel modules for Linux back in the day when, I don't know if you remember Adaptec cards when they had 4 ports and all that stuff. So like a lot of my
that might be even before my time, Jamie.
Yeah, see, look, I'm dating myself. So I'm 3COM cards, all that stuff. When Linux first came out,
3COM. Okay. Yeah.
Nobody wanted to support it, so the community wrote our own networking pieces. That's how I actually got involved in networking. But the reality is that like all those classes and lessons, I'm PMP certified, did all that stuff, and CCIE, all those things come into play when you design a system that you want to use. The cool thing about the AI is that you can design your system, right, especially with the chats, and then take use of it. The bad thing about it is you can design anything. So you can just go nuts. Like I said before, I used with this system here, I've literally wrecked my my computer just because I wasn't thinking. And then, further down, I have my region registries where everything's in a region, all my active sessions, so I can see. The idea is just giving yourself enough visibility into what they're doing, right? I've got rollback logs that I've set up, agent logs, I can track my life cycle, all of those things. Because once again, starting to use those agents, I quickly found out really, really quickly, because of the fact that you can't see everything, it can get away from you really fast.
I think that actually leads us into TechFirst's question about, are there any AWS customers or internally in AWS using MCP AI to implement production network changes? Any reference would be helpful. There is one actually. Oh, I don't know if I can find this. Eamon, one of our telco SAs, has been working with NTT Docomo on building AI systems to manage NTT's network. And they recently posted on a cool video. I'll see if I can find it here. Jamie, I don't know if you have any other examples, though, that you could share.
I do. Unfortunately, they're not publicly referenceable, but I can talk in generalities. A lot of it is coming down to POCing. Is what I've seen people using it for, where they'll have either another account or something where they'll spin something up, right? They'll have a cloud, somebody will make a CloudFormation template or whatever, and they spin it up and they just basically use the AI agents to crawl all over it. Where are the weak spots? How fast can it go? What can it do? How do I design it better? And at the end of that process, they'll get CFN templates that are a lot tighter than what they received, right? And then some customers are trying to do it where they just basically say, build me this, and it goes out and it builds it. But right now, again, they're building a lot of guardrails, right? The intent, tenants or whatever you will, for, hey, if you're building this network, it has to be all private, no IGWs. You have to be very explicit in how you want it to build and manage that network. The very first thing I tried to do is build a demo. and it put a bunch of VPCs out. Every single EC2 instance was on the public internet, right? It was just like the easiest way it could accomplish the task I gave it, which was so insecure.
Yeah, I get frustrated with laziness of any agents that I'm using. I feel like they take the shortcuts sometimes. Maybe when
Well,
capacity
you
is
whip your
scarce,
agents, right? You're like, do it now.
no, I'm nice to my agents, because when the AI overlords come in, I want to be on the good list. There's a link that we just posted. I think Jeff just posted it into the main thing. Thanks, Jeff. So beyond correlation, finding root causes in using a network digital twin graph and agentic AI. And so I think what the idea of this one is, and folks can take a read, but it's basically using telemetry data to build, like what you're doing, Jamie, build a graph database and build a digital twin or logical representation of the network, and then say, okay, well, what happens when things break? What flow-on effect happens? And you can get full visualization based on that, because you basically have a digital twin of your complete network deployment. But there are some diagrams here, but they're a little intense. Maybe we can get Eamon on to talk more about this one at some point.
That'd be cool.
Because I know there's been a bunch more work that's been happening in this space.
One of the things I'm trying to do with my agents is build a network visualizer. So I'm trying to get it so that when we can talk,
I've wanted that for years, man. That's
I'm close,
my dream.
Dude. I'm close. I can. It builds a diagram, but I need the diagram to be a little bit more. I want it. It could be better. Let's just put it that way, right? Right now it just builds a standard, like, what is it, mermaid kind of flowcharty diagram, and you can see what you've got on your network. It doesn't use AWS symbols or anything like that, but that might be a neat thing to do. Like maybe the next time you and I get on, you can be like, hey, bring up that network visualizer, see where it goes. I can show you how I built it and all that. And I would make it obviously publicly available. This is not anything that's going to be an actual AWS product. This is just a Jamie side project. But
converting JSONs into a usable diagram. I do love that if I'm doing some proof of concept testing and I'm working alongside an agent, I'm like, oh, tell me how to do this, or this is my problem, or I'm building this, or do that. I'm not actually letting it do the building for me. I'm doing the building, but I'm using it as an assistant, right? And then I would just say, give me a diagram of what we've been talking about. And you get I love ASCII art.
Yeah.
But, and actually ASCII art reminds me of IRC. And coming back full circle here, because we're almost out of time. Speaking of the coax cable T-piece junctions we mentioned at the start of our session here today, if you had a little the T-piece, if you had a block on the T-piece, you could unscrew that and the whole network ring goes down, right? My sister, when I was a young kid, she used to be on IRC talking to her friends. I would go and take the end connector off and a whole home network would go down. And you'd hear
I remember that.
In the other room. Yeah. So, but yeah.
If your network was long enough, if you remember, if you took the little resistor end off, right, it would only work for up to a certain length. But your network had to be long, your cable had to be long enough. So that's why we used to do cable loops. Right. Because when I used to work in the university, we'd always get kids that would come back on the 10 base T connectors and pull off the little resistor at the end, and you'd see them on their book bags as they're walking around, right? Like, hey, look what I did.
The whole university's offline.
So then what we did is we learned that, because of the fact that you're sending, if you remember back then, they used to have the solid core 10 base T, and then they started going into stranded. When they did the stranded, the way that works is because the electrons, they go on the edge. It's the skin effect. So you create more skin, more strands. Right. You can strengthen the signal so that after a certain computer, it would degrade. So that was kind of funny. But yeah, I remember that. Full circle.
Fun times. Yeah. There's a couple of questions here that we did miss. We are pretty much out of time. Noobs, so your views on micro-credentials versus old school certs like SSA CO3. Maybe we'll save that for another session. I think that's a pretty in-depth one.
Micro-credentials, I'm going to do a thumbs up just because again, the more that you can do validation and the more you have finite control over that validation, the better. Just make sure that you have the finite control and not your agent.
Yeah, that makes sense. Ken says there's a good AWS network MCP. We should check that one out. I don't know if you've got much detail on that one, Jamie, but we should talk more about that for sure.
Yeah, I use it for building.
And then Curious One too is talking about the AI thing. I don't know if you folks have seen that meme where You know, the Terminator comes in and there's a little girl hiding. You know, I feel like
That's a good one.
it gets reused a bunch. Anyway,
Yeah,
I think we're out of time. Jamie, as always, it's a pleasure, man.
It's a pleasure. I'm glad I could stay with you the whole thing. Once again, I apologize.
Yeah.
Thank you for the folks for the kind words about my my
Code with Sean was backing me up last time. He had some really good questions that we were talking about, so that was fun
Good
still
deal.
anyway. But thank you.
Good deal.